this puzzle together. It says at what rate? Okay, now we're back to business. They already gave us the rate of volume. I'm going to jot that down again. The rate of volume is 1/4 cubic something or other meter per minute. Now they want to know what is the rate that the water level is rising. So what variable are we going to call the rate that the water level is rising? What's that? Meters per minute would be the label for it, absolutely. So in terms of variables, you want to call it H? H for height? Is that what we're looking for, is the height? Ah, there you go. We're looking for the rate that the height is changing. We're looking for dH over dt. At what rate is the water level rising? That's how fast is h changing. In calculus, we call that dH over dt. Okay.
That sounds reasonable.
Gosh. All we have to work with, though, is dV over dt. So we're going to have to start with just a volume equation. Since they're giving us stuff as a derivative of volume, we're going to start with the volume equation and differentiate it so that we have dH over dt and we have dV over dt. Because that's what we're working with. So again, you're going to start out not with derivatives. You're going to start out with regular old everyday functions from your neighborhood, and you're going to differentiate them to form stuff with derivatives in them. In our case here, volume is going to be, well here, we're rising up this triangular piece. This is our height, this is our base, the depth is 6. The water level has not yet reached that stupid rectangular part on top. So all I really have to focus on is triangles, 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 because we're in the part of the pool that's triangular at this very moment in time. So let's write the volume of this triangle. 1/2 base height, that's my area, times 6, because that's my third dimension. That's the part that's going into the chalkboard. Or really, a better way of writing that is probably 3 BH. Yeah, 6. Here's the thing. If you were to, because eventually we have to differentiate volume, because this is what we're working with. We're working with derivative of volume, and we want derivative of height. If you differentiated this equation right now, the way it's written, you would have a dV over dt variable, which is not a problem. We got something for that, right? And then you'd have to run a product rule on this little nightmare, which means you would have a b variable, which isn't really a problem, because we can find that. We found it over here. You would have a dH over dt variable, which isn't a problem, because you want that. You want to have that variable. Plus, then you'd come back the other way on the product rule. You'd have an h variable, which I guess really isn't a problem either, because we could figure that out. It's 1. And then you'd have a dB over dt. That would kind of stink, because we don't know that. We don't really have a way of getting it. Well, there's
the way you should.
Gosh, if only differentiating v right now would give, let's just say, too many variables. We don't have a way of dealing with all those variables. We need more information from the problem. If only there were some mathematical technique that would allow you to take out one variable and put in an equivalent expression. Yeah, if you could somehow substitute one thing for another that meant the same thing, That would be, gosh.
I have no idea what he's talking about.
Wouldn't that be nice if there was such an algebraic technique?
I'm guessing.
I don't know if there is, let's just put the in.
Yeah, I'd put D and E right
Yeah, but Ben's right. We do want to substitute before you differentiate. By if you can get rid of one variable now, you will get rid of two variables in your derivative. Because there will be no more product rule. Product rule brings variables in from every corner in the world. If you can eliminate having to use product rule, then you eliminate a lot of those variables coming in and making it a lot simpler problem. So, I still want my dH over dt. So guess which variable I want to get rid of?
B.
Yes.
now. 6.
Substitute something for b, so that we'll still have an h or a dH over dt in our product. If we get rid of the h, then we won't have a dH over dt, and we won't know what it equals.
6.
Okay, this.
Or 12.
18H.
Yeah, here's the thing. We want to keep it in terms of b. At this particular moment, yes, b is 6. But in general, at any time, we found out from the first part, the height is equal to, or actually no, it's 6 times the height is equal to the base, right? We found that out in the first part of the problem.
Yeah.
It takes 6 of these to make 1 of these. Because when this is 2, this was 12. When this was 1, this was 6. So you don't want to plug in a number, and I'm glad you brought that up. You don't want to plug in a number like 6 until you've actually differentiated.
So then we would take the 16.
You keep it like broad.
Right. So we're gonna take out the b and we're gonna put in a 6h before we differentiate. So v used to say 3bh, now v is gonna say 6h. Which is good, because when we differentiate, we'll still get our dH over dt. We want to preserve that, so we can actually, answer the stupid question. When you multiply all this out, what's a better way of writing this?
18h squared.
18h squared. All right, I like differentiating this a whole lot better than differentiating that. Let's differentiate it. V is going to become dV over dt. 18h squared is going to become
16 or 36 dH over dt.
good. 36 is your new coefficient. H stays the same.
dH over
2 drops to a power of 1. And then you chain on the derivative of the h quantity, which is dH over dt.
plug in
Yeah. Once you've differentiated, and only once you've differentiated, can you start plugging in constants for this stuff. Don't plug in constants until you've differentiated. Okay. Otherwise, the whole thing just blows up. It's quite dangerous. dV over dt, let's plug in 1/4. For h, at this moment, we can say h equals what? 1. dH over dt we don't know, but that's okay, because that's what we're trying to figure out.
Oh, why 1? Just us?
Because at this moment in the problem, they said the height was 1.
Oh.
And because we've differentiated, now we can plug that constant in. So let's divide both sides by 36. A 4th divided by a 36 is going to be like a 4th times a 36th.
So
144 show up.
Weird.
And then a long time ago, someone told me what the label was going to be. Meters per minute. Meters because that's what you measure height in, and per minute because it's a rate. That's the idea. There's a lot to it, but it's really just setting up a formula with geometry and then differentiating it with calculus. And then isolating stuff with algebra. It's really, it's everything.